We are starting our unit on probability, and today we're starting with permutations and combinations. So, first we're going to talk about the idea of the fundamental counting principle. Fundamental counting principle. All right. If there are n items and m1 ways to choose the first item and m2 ways to choose the second item, and after the first item has been chosen, so on, there are, okay, so the idea is we have so many items to pick and we have so many ways to pick the first item. What you're going to do is you're going to multiply m sub 1 times m sub 2 times m sub 3 and then dot, dot, dot. You are basically multiplying all possible combinations together. So I'm going to show you what this actually means. Let's look at an example here. It says for lunch special, you can choose an entree. There are 3 entrees, pizza, chicken, or beef. So I'm going to put a 3 above the word entree. You can pick a drink, which is milk, juice, punch, or iced tea. How many drinks is that to choose from? 4 drinks to choose from. And it says 1 side dish, coleslaw, salad, or fruit. So how many side dishes are there? There are 3. Okay. Now, we are going to use something called the fundamental counting principle. We multiply all the possible ways of these outcomes. There's 3 outcomes for pizza. So we'd take 3 times how many outcomes there are to pick as a drink, 4, times how many outcomes there are for our sides, 3. So take 3 times 4, which is 12, and then 12 times 3 is? 36. So you could say that there are 36 meal options. Are there 36 meals sitting there? No, but there are 36 meal options. So let me show you why. We're not going to take the time to write this out because we use a fundamental counting principle. If you look at this, we had pizza was 1 entree, and then chicken, and then beef, right? Those are my entree options. So if you picked pizza, after you picked pizza, you had 4 drink options, which was milk, juice, punch, or tea. If you picked chicken, you had 4 juice options, same 4. And if you picked beef, you had 4 juice options. So you're drawing out this chart. Now, once you picked your drink, then you could pick one of 3 side dishes. I didn't leave myself enough room. But I could have had, coleslaw, a salad, or fruit. Then off of juice, I could have had coleslaw, salad, or fruit. And you see, off of each of these, I would have 3 more. So if you look at this, if I pick pizza, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ways I could have pizza. I have pizza with milk and coleslaw, or pizza with milk and a salad. So each item, there were 12 possibilities. And if you think about it, that's because we took this, and we multiplied it by 4 different things, and each of those were multiplied 3 times. So you could draw out this chart for each of these, and then you would see each entree has 12 outcomes. And that's why we had 36. So the fundamental counting principle is a shortcut, so you don't have to sketch out all the ways possible. So you have a make your own story adventure. It lets you choose 6 starting points. So you have to pick one of those starting points, and then 4 plot choices and 5 possible endings. How many adventures are there? So you had 6 starting points. So you'd pick one of those 6. So we had 6 outcomes. We multiply it by the 4 plot choices. And we multiply that by the 5 possible endings. So again, it would sort of look like this array of each option being connected. So 6 times 4 times 5. Do you agree with 120?
Yeah.
Okay. So if we were labeling this, we could say 124 adventures or adventure options. This would have been 36 meal combinations. So again, it's not that there's 36 meals sitting out there, but you can make 36 different combinations. You can make 120 different combinations of stories. All right, so take a second and read this last one and see what you think.
What did you say?
So we have a password. It's 4 letters followed by 1 digit. There are uppercase letters A and lowercase letters A may be used and considered different. All right, well, first of all, how many letters are in the alphabet?
24.
26. And then if you have 26 capital letters and 26 lowercase letters, how many options do you have? 52. 26 and 20. So a capital A and a lowercase a are two different options. So you get the idea. You have 26 capital letters, 26 lowercase letters. So you have 52 letters to choose from.
Wait, 52 times 4 is not.
No, but that's the thing. Okay. A lot of us want to do 52 times 4. Think about slots. Now, it says here how many passwords are possible. Does it say that you can't repeat a letter or a digit? Okay. Now, these are going to be my letters. I have 4 letters that I need to pick and then 1 number. Now, we'll come back to the numbers. So I have 52 letter options for my first letter. If I pick the letter A, capital A, I'll put it here. And then how many options do I have for my second letter? It didn't say you can't repeat, so I still have all 52. And how many letters do I have for my third letter? 52. How many letters can I pick from my fourth letter?
It's just the same
52. So it's the idea that I have 52 options for the first times 52 times I'm multiplying all my possible outcomes together. So you understand why it's not 52 times 4. It's 52 options. I'm multiplying all my options together. Now, how many digits are there? Hold on. Look at your calculators or a keypad. There are 10 digits because 0 through 9 are digits. Now, a number like 11 is a double digit. 13 consists of 2 digits. So the digits are only 0 through 9, but there are 10 digits.
It's 65,804.
Whoa.
That's close to a million.
If you multiply these numbers, the shortcut I would do would be 52 to the 4th times 10. 52 times 52 is already a pretty big number. We should be getting out 73,116,160 password possibilities. Did we put that in the calculator? Do we agree with that now?
I agree.
Okay. So if you think about it, when you go to do a password and they tell you it's not a good enough password and you're frustrated, that's because they're trying to get you to use uppercase, lowercase letters, and symbols because it creates that many more passwords and it's harder for a thing to crack. All right, so your fundamental counting principle is when you multiply all the possible outcomes together. Now, the next idea is called a permutation. We're going to let our calculators do the work for us, but I'm going to show you what a permutation is and why. So a permutation is a selection of group of objects, and the order is important. So I might ask you, like, how many ways can you group this? If the order matters because you're putting them in a position like president, vice president, secretary, treasurer. If you're lining kids up for a roster, a batting order, you have a 1 through whatever on your batting list. If you're putting kids in positions on a basketball field, on a football field, if you're putting kids in a seating chart, again, those order, that matters. So they would be permutations. Now, if I just say, hey, I have 20 students and I need a group of 3 of you to come volunteer, the order doesn't matter. But if I have 20 kids and I say, I need the top 3 students in this class, then we are ranking 1, 2, and 3, and the order does matter. So permutation is when there is an order that is important. Now, in order to understand permutations, we have to understand this idea of factorial. Factorial looks like this. There's an example down here. It's 5 with an exclamation point. And that factorial is basically the product of all the natural numbers less than or equal to the number, except we don't use 0. And 0 factorial is 1, just like anything to the power of 0 is 1. So an example, if you see 5 with an exclamation point, it's saying take 5 times 4 times 3 times 2 times 1. All right, well, take that in your calculator. So it's 5 times 4 times 3 times 2 times 1, please. You said 120? Okay. Now, there is a quicker way of doing that in your calculator. So depending on which calculator you have, you should all have the probability key. So here's 2 calculators. If I go into here and you go to this probability key, so here it is on both calculators. Do you see it? Sort of top left. Hit probability, and you see this NPR, that's our permutation. NCR is going to be the next thing we learn, combination. And then you have this exclamation point. Same thing here, but it goes across. So you want to arrow, whoops, sorry, you want to arrow down and grab that factorial. But notice it says answer factorial. And if I do this over here, it says answer factorial. So we want to make sure we put in the 5. I'm taking 5 factorial. So type in the 5, hit that probability key, and then either arrow down and select or arrow over and select. Now that 5 factorial is really quick. I don't have to multiply all those numbers. They both give me the outcome of 120. It is the second key down, second key over from the left. Okay, so it says PRB on it. Okay, so we don't have to write that out. We can use that factorial key. But I wanted you to understand what it is. Now, this says NPR. N is the number of items you have, and R is how many I'm grouping. So I use the example that I have 20 students in a class, and I'm going to put 3 of them in order, the top 3 students. So my N would be 20, and the one, how many am I grouping? That's 3. So there's a formula. NPR is N factorial over N minus R factorial. And that's what it has to look like. So you take the number of items, factorial, and then you divide by N minus R, and then the factorial on the outside. All right, so when you guys are looking at this, again, we are going to look at this word problem, but that's what's hard about word problem is you have to figure out what do they ask me to do. This says how many ways. Okay, so I'm looking for sort of combinations, how many groupings I can make to select a president, vice president, and secretary from a group of 5 people. So my N, the number of people I have is 5, and the group I'm making is 3. Does the order matter? Yes, because I'm putting them in positions. So since the order matters, it's going to be a permutation. So when I go to type this in my calculator, I'm going to type in the 5. I'm going to go to that permutation key, so it will look like this in my calculator. 5 NPR 3. Now, some calculators do it differently. So here we go. We have 5 items. I'm going to go to my probability and select the NPR, and then I'm selecting 3. That's what it looks like in this calculator, and it's telling me there's 60 ways I can pull 3 people and put them in position out of 5. Guys, there's only 5 people there, but there's 60 ways for me to rank a president, vice president, and secretary. So there's 60 groups that I can make. Now, if you're using this calculator, same thing. I'm going to type that 5 in, probability, and then it actually puts it sort of the same way. Some calculators will have like the little boxes to put it in, but we get that same output. So put in your 5, NPR 3. If I mistakenly do it backwards, it's going to give me an error. It won't do it. I can't select 5 people out of 3. Okay, so I have 60 ways of doing this. Now, I'm going to show you this once, and we're just going to let the calculator do the work. How does this formula relate to it? Well, our N was 5, so we'd say 5 factorial over 5 minus 3 factorial. So if I'm cleaning this up, I have 5 factorial over 2 factorial. So I would actually write out 5 times 4 times 3 times 2 times 1, and the bottom would be 2 times 1. And if you remember anything about fractions, we can cancel these guys, and what's left is 5 times 4 times what? 3, and guess what that amounts to? 60. So I can do this by hand, but we're going to let the calculator do that for us. So read this, and now we've separated everything. So we're only focusing on permutation. So I want you to tell me why it's a permutation. We have 9 paintings from an artist, and we're going to display 4 from left to right along a wall. How many ways can the gallery select and display 4 paintings? So why does the order matter? Like, I'm telling you the order matters for these problems, but can you tell me why?
I cannot tell you why.
Well, you're picking 4 pictures and you're putting them in from left to right. So the order does matter, right? Because you have the first picture, second, third, and fourth from left to right. So they are not just randomly saying, hey, we need 4 of these paintings. We're going to have 4 of these paintings and we're going to line them up. And it is a big deal. Whatever picture is first, if it doesn't grab someone's attention, they might not look at the other ones. Or whatever picture's last, they want to be the best because they want people leaving thinking, oh, look at this amazing artwork. So the order matters because it's going from left to right. For our NPR, the N is 9 and the P is 4. Now, what it really looks like is you'd write 9p4. That's what it looks like. That's the answer, but this is how it looks in the calculator. So let's find out how many there are. We would go with 9, probability key, and 4. 3,024 ways to arrange these pictures. So you have the idea that you pick 4 of these pictures out of the 9, and then you can rearrange these pictures multiple ways, and then you could change one picture out and then rearrange them just the same. All right, we have awards being given out at a costume party. How many ways can most creative, silliest, and best costume be awarded to 8 contestants if no one gets more than 1 award? Now that's important. So no one's getting 2 awards. Okay, the order matters because we have different awards, so they're like different positions. And it's going to be a permutation. So we have NPR. What is our N? We have 8 total people, and how many are they picking for awards? 3. So what does 8P3 give us? 8P3. 336. So there's 336 ways. 3 people can be selected for these. So you see the number's a lot bigger than you thought. A lot of people just take 3 times 8 and say, oh, there's 24. Okay, now, next one's a little bit different. How many ways can a 2-digit number be formed by using only the digits 5 through 9 and by each digit only being used once? So you can't repeat a digit. All right, a 2-digit number means we're only picking 2 numbers. How many numbers are we picking from? The digits 5 through 9.
5.
Yeah, I would take a minute because some people subtract and say 4, but 5 through 9, 1, 2, 3, wait, hold on. 1, 2, 3, 4, 5 numbers. Okay, so it is going to be a permutation because we're making a password. A 1, 2, 3, 4 is different than a 2, 3, 1. Agreed?
So what did you just ask us to do?
So we're going to make a 2-digit number using the digits 5 through 9. So this is, so it says you can only use each digit once. So let's say I have the number 5, 6, 7, 8. You understand that's different than, you understand? Oh, you're right. Let's say I pick the numbers 5, 6. That's different than 6, 5. Agreed? It's not going to unlock anything. So we want a 2-digit combination, but we're only using 5 numbers.
5 and 9.
So it would be 5P2. This is your R. We're selecting 2 out of our 5. And it can't be repeated. That's important. All right, so what is 5P2? Put that in your calculator. 20? Do we agree with 20? Okay. When we're done. All right, next idea. The order doesn't matter, and it's called a combination. A combination is a grouping in terms where the order doesn't matter. So the example I used before is I have a class of 20, and I just need 3 people to volunteer. It doesn't matter who you are and what, there's no ranking. There's no first, second, and third person in charge. So that's a combination. How many groups can I make out of this? Or the other one, I would make a group and then I would rearrange them. So there is a formula for combinations, and we're going to get less combinations than we did permutations, and I'll show you an example tomorrow. Like, we'll do a live example. This is the formula. We have n factorial, so the total number is over r factorial times n minus r. So this is a permutation, just like that, but we're going to divide by that r factorial. It's going to cut that down.
What is at the end of that?
Factorial?
No.
R? That's an R. Okay. So again, we could write this out. We're going to let the calculator do the work for us. It says Katie's going to adopt kittens from a litter of 11. How many ways can she choose a group of 3 kittens? She's not picking her top 3 kittens. She's not ranking first, second. She's just picking 3 kittens that she wants to take home. That is why this is called a combination. So NCR. So this is our N. Total number is 11, and she's picking 3. So we would have 11C3. All right, so here we go. 11C and then 3. There's 165 ways she can pick these cats. So that means picture 11 cats sitting there, and you pick 3. And then you say, you know what, I don't want this one, he bit me. You put one cat back and you pick up another cat. And it's just sort of how many ways can you sort of trade out and remake these combinations. Now, just to show you the difference, I'm going to leave that in the calculator. Let's say she had to rank her top 3 cats. That would be a permutation. Look at the difference in the numbers. If she was ranking the top 3 out of 11, she'd get 990 ways to rank them versus 165 groups. So she can group them 165 ways, but each group can be rearranged. Okay, so you said how. So think about this. Let's say I want to pick 3 cats, right? Here are my 3 slots. I have 11 cats to pick from. So when I go to pick my first cat, I have 11 options. Now, the cat that I pick is off to the side in a little carrier to take home. How many cats are left for me to pick my next one? 10 cats. Put that in the carrier to take home. How many cats are still waiting for an adoption? 9. Guys, this is the fundamental counting principle. 11 times 10 times 9. Add 11 options, 10 options, and 9 options. All right, we'll take 11 times 10 times 9. That's 990 ways that I could rank and select a cat. That's the idea that the order matters. I picked my first one. I had all 11 cats. Take a cat out. I only have 10. Take a cat out. I only have 9. I am using that idea of multiplying all possibilities for each one, just like we did for this. But if we're just doing groups, I only have 165 options. All right, we have a swim team with 8 swimmers. 2 swimmers will be selected in the first heat. How many ways will swimmers be selected? Okay, a first heat, it just means you have too many kids to swim at the same time. So the first grouping, but there's no ranking. So how many total do I have? 8, that's N. How many are we picking? 2, that's R. And because we're not putting them in lane 1 and lane 2, the order doesn't matter, so it's a combination.
How many ways can the swimmers be selected?
I have 8 people lined up on the pool deck.
What do we select?
I have 8 people lined up on the pool deck, and I'm going to say, you 2, jump in heat 1.
Yeah, that's one way to do that.
Yeah, and then, but then I can nope, because then I say, oh, never mind, you go back, and I pull another kid.
It should be how many kids can be.
So it's going to be 8 combination 2. Did anyone crunch that number for me? 28. Do we agree with that? Okay. And the order doesn't matter. Just to throw it out there, if the order mattered, if we were ranking heat 1, lane 2, and if like lane 1's your fastest lane, if we did 8 permutation 2, we'd have 56 ways versus the 28 that we had when the order didn't matter.